This is the solution video for the revision sheet on Algebra 1. And the first question requires us to divide a cubic. Now, there's a couple of ways of doing this. I'm going to use the array method. So for a cubic, I need to draw a 6-box grid for my array. On the outside, I'm going to write down 2x minus 1. That's my linear factor. In the first box, I'm going to fill in my first term. In the last box, I'm filling in my last term. And then I'm going to complete the array. So on top, I'm going to need x squared to multiply by 2x to give me the 2x cubed. Underneath that, I can fill in minus 1x squared. Over here, I'm thinking about what I can put on top to multiply by minus 1 in order to make the plus 1 in the corner. And that's going to be a minus 1, allowing me to fill in this box, which is minus 2x. And then I'm going to be able to go back and have a look at my original cubic to decide on the values that go in the middle boxes. So I want a target of minus x squared or minus 1x squared. I'm already at that. I don't need any more x squareds. That can be a 0. I need a target of minus 2 for my x terms. Again, I'm already at that. So I don't need anything extra for my x terms. And I'm going to have a 0x in the middle on top. So my solution there is the quadratic factor, which is written on the top of my array. You can have done this using the long division method as well. That's totally fine. You should get the same solution. Next, we have a difference of 2 cubes question. With these, it's a really good plan to write the formula down first. You do need to know this formula. It's not in the log tables. So now I must decide what the cubes are in my expression. So I've filled those in, and now I'm going to fill the 2 and the 3a into the correct positions in the formula. In that second bracket, it's a good plan to put brackets around everything that you're subbing in, and then just do a little bit of simplification to get your final answer. Question 3 is next. We're asked to fully factorise. If we're told to fully factorise, that usually means there's a few steps in the process, and a lot of the time it means look out for a highest common factor first. I can see that in this case because 10 will go into both of these terms. And now looking at that y squared minus 4, I can see that it's actually a difference of 2 squares, so I can continue on with my factorisation of that. First, I'll identify what's being squared, and then I'll factorise fully. Next, we have question 4. We have to simplify this algebraic fraction, and I can see that there's some stuff happening in the numerator and the denominator. They're both fairly complicated looking. And remember, in this kind of setup, what's happening is that the numerator is being divided by the denominator. Now, there's not much I can do with the denominator as it is, but the numerator needs a bit of tidying up. So I'm going to look at that first of all. And I want to write this as one fraction. So I'm going to start off by putting that 1 over 1, and then I'll get a common denominator for that, and that's going to be x. And then looking back to my 2 original fractions, I can see that, well, to get from 1 to x, I have to times by x. So I'll have to times the top by x as well. And in the second fraction, I don't need to do anything to x to turn it into x, so I can leave the 3 as it is. So I've got x plus 3 over x. So now I want to go back and look at my overall question, which is my numerator over my denominator. So numerator divided by denominator. Now notice how the denominator is a fraction. If I want to divide by a fraction, I flip and multiply. So I'll leave the numerator set up as it is now, x plus 3 over x. And then I'm going to divide by x plus 3 over x minus 3. So if I'm dividing by a fraction, I'm going to flip and multiply, and it's this guy that I'm going to flip. I'm avoiding using the multiplication symbol in the middle in case it gets mistaken for an x, because there's so many x's floating around in this. And I'm having a look now at my numerator and denominator, and I see that x plus 3 is a factor of the numerator and the denominator. So both of those can go. And my solution then is going to be x minus 3 over x. And I stop here. It's not possible for me to factorise any further because there is nothing that I can factorise out of x minus 3 that will allow me to cancel off with the x in the bottom. So that's the end of my question. Question 5 is a binomial expansion question. We'll need to use the NCR button on our calculator for this. So my layout for this is going to have several terms. The first term is going to be 4, choose 0. That'll be the NCR button in a second. 3x to the 4 minus 2y to the power of 0. Okay, but I'm going to have other terms as well. And what's going to happen is with each one, I'm going to increase my value in this position, decrease my value here, and increase my value here. So I'll see a pattern. Notice that I've stuck a plus in front of each of those to link all these terms together. And then I'm going to evaluate each of them. Remember that anything to the power of 0 is always going to be just 1. And again, on that last line there, 3x to the power of 0 is 1. Now I want to take all this information here and tidy it up and write it in one line at the end. And there's my final answer. And just to note something interesting, that when I have a negative in the middle of a binomial expansion, I'm going to see alternating positives and negatives as I go along my solution. So I've got positive, negative, positive, negative, positive. That should always happen if there's a minus in the middle. Finally, question 6, it's an identities question. There's a couple of ways of going about it. I can multiply out the left-hand side and then allow like terms to be equal, or I can also use the array method to divide if I like. Both will get me the answer. I'm going to do this one using algebraic identities. So I'm going to multiply out x minus 5 by itself 3 times. Again, don't forget, if you're doing this, don't try to do all 3 in one go. Take it 2 at a time. So I'll do x minus 5 times x minus 5 first of all, and then I'll multiply out one more time. And I can see pretty clearly there when I write in the right-hand side x cubed plus px squared plus qx minus 125 directly underneath what I'm after getting as my result. I can see that the p value is the coefficient of x squared, the q value is the coefficient of x. So p equals minus 15 and q equals 75.